Hello guys, and welcome back to my YouTube channel. In this video, we're going to be talking about other types of functions. So we are going to start with the first type, that is even functions. So this is the first type, that is even functions. And in this type of function, what you need to know is that f of minus x should be equal to f of x. Okay, it looks very easy, so let me just go ahead and give an example. Okay, let's say we have f of x is equal to x squared. So let's say we want to test for f of 2. Let's say we want to test if f of 2 is equal to f of minus 2. So let's substitute. So f of 2 is going to be 2 squared, which is 4. And f of minus 2 is going to be minus 2 squared, which is still 4. So from here we can see that this function is an even function. Yeah, yes, from there, that's what we can see. Okay, let us take another example. Let's see f of x equal to x squared plus 1. Let's check this out. So our f of x is this. Our f of minus x is going to be minus x squared plus 1. So from here, this is simply going to be x squared plus 1. So they are the same. Our f of x is equal to our f of minus x. And here we say that this function is an even function. Now, all functions cannot be even, definitely. So this takes us to the next type of functions, that is the odd functions. So in this case, we have that f of minus x should be equal to minus f of x. This is the case where it is an odd function. Okay, so let me take a quick example. So let's say our f of x is equal to x cubed plus x. Okay, let's determine whether this function is an odd function or not. Okay, so let's have f of minus x. So remember, f of minus x should be equal to minus f of x. So f of minus x is equal to minus x cubed plus x cubed. Here we're just doing a simple substitution. We're just substituting minus x into our f of x function. So that is what we have. And to further simplify this, we have minus x cubed. Oh, sorry, this is minus. So here is just minus x, sorry, that is what it should be. So this is minus x cubed minus x. This is what we have. And let's say we want to factor out this negative number. So we're going to have minus into x cubed plus x. And check it out. What is this? X cubed plus x is our f of x. So this is simply equal to minus f of x. And guess what? What can we conclude from here? We can simply conclude that our f of x, our f of minus x is equal to our minus f of x. And that tells us that this is simply an odd function. So for odd functions, remember f of minus x should be equal to minus f of x, and for even functions, f of minus x should be equal to f of x. So here we do simple substitutions in order to know whether it is an even or odd function. Okay, but yes, remember I said not all functions are even or odd. So yes, not all functions are even or odd. So there are cases where the function is neither even nor odd. Let's take an example. So let's say our f of x is equal to x squared plus x. So let's check whether it is even or odd. So for even function, remember when we solve this, our f of x should be equal to our f of minus x. And for odd functions, our f of minus x should be equal to minus f of x. So this we should end up here or here. So let's try this. Let's take f of minus x and see what it will give us. So we have minus x squared plus minus x. So this gives us minus x squared minus x. Okay. Oh, sorry. This should not be here. It is squaring, so the negative sign should not be there. Okay, so it's going to give us x squared minus x. So check it out. We can see that this is definitely not equal to our f of x function. As you can see, this and this are not equal, and there's no way that you can leave from here and make it to be odd. So in this case, we can say that it is neither even nor odd. So that is what we can conclude in this case. So remember, not all functions are even or odd. They can be even, they can be odd. Okay, now let's go to the next type of functions. That is, we have periodic functions. Periodic functions. Okay, so periodic functions are in this form. Let me see. We have g of x equal to a certain x squared, and we are given a range. Let's say this. So these are periodic functions. Periodic functions are of this form, and there is another type which is a compound periodic function, where in that case we have, okay, let me just say a compound periodic function. A compound periodic function, let me say it's just a periodic function with two or more different definitions, because here it has only a single definition, so this will have two or more different definitions. Like for example, we have something like this. We have A for this range. We have AX plus B for this range. And then we have another one for this other range. So here we had only a single definition. Here we have only a single definition. We had only one range with one definition. But here we have different ranges with different definitions. So that is a compound function. Okay. Okay, let me just take an example at once. Okay, say we have g of x is equal to x plus 2 with this range, and we are asked to find g of minus 6. Okay, here, okay, a period is always given. Let's say we are told with a period of 4. So, okay, so here we have minus 6. But if, let's check in this range. Here, this ranges from x less than 2. This ranges from x greater than or equal to 0 to x less than 2. Okay, here we have minus 6. If we notice, minus 6 is not in this range. So that is where we have to use a different approach, a different formula, which is f of x equal to f of x plus kc. kc in the case where c, is our period, and our period was given, which is 4, while x and k are certain constants in which we need to operate to give us this minus 6. So in this case, we are going to have, so here we are going to have our x as 2, our k will be minus 2 times our period, which was given earlier, 4. So let's take this. So minus 2 times 4 is minus 8, and if we have 2 minus 8, that will give us minus 6. So here, these values for x and k, they are just certain values in which we need to operate to give us. Okay, but let me give you guys a certain tactic on how to come out with our x and our k. So here we have minus 6, we have a period of 4. To get these numbers, we have a negative number, so let's add 4 to this negative number until it gives us a positive number. So let's say minus 6 plus 4. What does this give us? It gives us minus 2. Let's go again. Minus 2 plus 4. What does it give us? It gives us 2. So here we finally have 2. So how many times did we add 4 to minus 6 to give us this 2? We added it 2 times. And what was our last value when we finally added the 4? It was 2. So here we have 2, here we have 2. This sign, you have to know how to place the sign, which sign to place there in order to give you what you want, because all these have to result to minus 6. Okay, but that is not all. So from here, remember, if minus 6 was in this range, then we would have simply just taken, since this is g of minus x, we could just simply replace minus 6 here into this equation. But since it was not in the range, we had to find a way. So here we have found a way. Here we were looking for x. So now we have seen that our x is 2. So from here, we take this 2, which is our x, and substitute it into the g of x function. So g of x is equal to x plus 2. So now we know that our x is 2. So we have 2 plus 2. And finally, g of minus 6 gives us, sorry, this here is 2, not 4. This is 4. Sorry. Is 2. So finally, that gives us 4. So our g of minus 6 is 4. Remember, the minus 6 was not in the range. It was not in the range. That was why we had to go through this formula. To have x. Remember, the formula is f of x equal to f into x plus kc. So we had to find that x in order to finally substitute it into the function, because minus 6 was not in our range. Okay, let's have another quick example. Let's say f of x is x plus 1 for this range, minus 1 less than or equal to x less than 1, and f of x equal to f of x plus 3 or x. Okay, so in this case, when we have something in this form, here we were not given a period. When we have something in this form, 3 is our period. So here we have a period of 3. Okay, now we have to find f of minus 13. Okay, let's evaluate. Minus 13. This range, it ranges from x greater than or equal to minus 1 to x less than 1. So minus 13 is definitely not in our range. And this one, it is for every x. But minus 13 is a negative number, so it will not work. So here again, we use our formula, which says f of x equal to f of x plus kc in order to find our x. So remember, if minus 13 was in any of the ranges above, then we would simply substitute it into the respective formula. If minus 13 was in this range, then we will substitute it in this function. If minus 13 was in this range, we would substitute it in this function. So it just depends. So here we have a period of 3. So here we start again. We put our period. Our period is 3. So now we need to find the values. Now let's evaluate this. Okay, we have minus 13. We start. Minus 13 plus 3. What does it give us? Minus 10. We go again. Minus 10 plus 3. That is minus 7. Minus 7 plus 3. That is minus 4. Minus 4 plus 3. That is minus 1. Minus 1 plus 3. That gives us 2. Okay, so how many times did we add 3 to minus 13 in order to give us our final positive number. So how many times this is? 1, 2, 3, 4, 5. Okay, so here we have 5 here. And what is our last number remaining? The last number we have after adding our 3 is the last positive number we have, because remember we are adding 3 to minus 13 to give us a positive number. Okay, that is 2, so we have 2 here. Okay, now we need to diagonal our signs, so we need to put a minus sign here. Okay, that is that. So if you evaluate this is 5 times 3, that is 15. 2 minus 15, that is minus 13. So this gives us what we want. So this 2 is our x. So we simply substitute it in the function. So f of 2 equal to 2 plus 1, which is equal to 3. And that is how we have it. Now let's go to the next type of functions, which is the continuity functions. Yes, we have the continuity functions. Sorry, the continuous function. Continuous function. The continuous function. Okay, in this type of function, the function is also defined on an interval like the rest. So let me just give you an example. So let's say we have f of x equal to x squared minus x minus 12 cx minus 8. Here for this range, okay, so that is that. Okay, so here we need to look for a point of continuity. A point of continuity. Here we have x greater than or equal to 0 and x less than or equal to 3. Here we have x greater than or equal to 3 and x less than 7. So from here you can clearly see a point of continuity. This is a range and continues with this. So 3 is our point of continuity. Okay, to solve this question then, okay, let me just give a question. Let's say we are given this and we are to find the value of c. Let's say we are given that and we have to find the value of c. So if, or let me say, since the function is continuous, then the limits of x tends to 3 of f of x is equal to the limit x tends to positive 3 of f of x. So this is how it is being done. So this is it. Okay, so since 3 is our point of continuity, so we say since f of x is continuous, then the limit of x tends to 3 to minus 3 of f of x is equal to the limit as x tends to positive 3 of f of x. Okay, so since x tends to 3, so here we're going to be substituting x with 3 since 3 is our point of continuity and here x tends to 3. So we take each case. Let's take the limits of x tends to 3 to the minus f of x. So this is going to be this first equation. Why? Because here x is less than 3. X is going below 3. So it's going to be x tends to 3 to the minus, because here x is going below 3. So let's substitute 3 in that equation. We're going to have 3 squared minus 3. Sorry, this is minus 12. Okay, from there we are going to have minus 6. Sorry, minus, yes. So this is the limit as x tends to minus 2, 3 to the minus. So let's say for this one, limit as x tends to the positive 3. So here x is going above 3, because here we can see clearly that x is greater than or equal to 3. That means x is going above 3, and here x is going below 3. So we are going to substitute this 3 in this other formula. So here we are going to have 3c minus 8. But remember, they set the limit as x. They said since f of x is continuous, or as long as f of x is continuous, that means that the limit of f of x as x tends to 3 to the minus is equal to the limit of f of x as x tends to the 3 to the plus. So we are going to equate them. Since they said, since it is continuous, then it can be equated. Okay, so we are going to have minus 6 equated to 3c minus 8. So remember, the question said we are finding the value of c. So we are going to make c this, we are going to bring like terms together. So we have 3c equal to minus 6 plus 8. We simply took this over here, and remember the sign always changes when it crosses an equality sign. So here we have 3c equal to 2. So now here we are going to divide both sides by 3, since we are looking for the value of c. So this will cancel, and so we are left with our c, which is equal to 2 on 3. So that is it. So this continuous functions always comes, it is in this form. So when you have equation, you can be able to tackle the question. And periodic functions, remember, if it is not in the range, then we are going to use this formula. So also remember the even and odd functions we had above, and that should be all. Okay, that is all for today, guys. Thanks for watching the video, and I'll see you guys in the next video.